So, uh, here is the topic what we have to start, because we have not yet started gravitational na,
No, sir, no.
with you. Okay, so this is the first lesson of gravitation for you, and then we will continue inshallah. Gravitational field. What is actually asked in this gravitational forces chapter? This is a huge chapter, and when we talk about this chapter, there are several areas, or several questions which are asked to us. They are linked with, centripetal force, but most of the time they are independent questions. Centripetal force is involved to somehow, so we have to remember that by all means. So here is the list of the topics what we have to go through, right? I mean, this topic, this chapter consists of gravitational fields, then gravitational law, or Newton's law of gravitation, then gravitational field strength. Although they are the same topics, but the gravitational field strength is an extensive topic of gravitational field. Then gravitational potential energy, and then gravitational potential, they both are related with each other. Okay. Then planetary motion, most of the questions are asked from planetary motion. That's why I just put 3 stars to that. So planetary motion.
No, put.
Yes.
Yes, sir.
Okay, do you have any question?
No, sir.
Okay, so planetary motion is one of the topic, but I mean, one of the most, I mean, big partner of this, or big contributor of the questions from in the gravitational force. And then we have binary stars. Actually, when we talk about binary stars now, so binary stars have a link with gravitational potential energies, I mean gravitational energies, and that has a link with field strength, centripetal force, and all that stuff. So I believe that we will talk about that in detail step by step. So let's talk about the gravitational field first. As I told you, that for perception, what does it mean by a field? What comes to your mind when you read this word here,
Sir,
field?
field, I think an area.
Yes. So
Mm.
that is why I just put this definition at the top. It is, although this definition has been changed in exam now, this is not that definition what you have to write in exam, but actually, field is that area around a massive body, or around any object in which it is influential. Simple. If it is gravitational field, so definitely I would be talking about the
Gravity.
influence of gravity. So this was actually that area or the space around a mass in which gravitational force can be experienced by any other body. So this was the perception. I mean, you can make this thing clear to any of the person, either that person knows physics or not, physics principles or not, but this makes a clear sense. But in exam, we are bound to write uh, a statement here,
Mm.
exam definition, that is, this is your exam definition, that this is actually amended in the syllabus in the previous year, that the gravitational field is the force experienced by a unit mass at a point. I mean to say, it is simply said that it is force per unit mass. If you have um, if you see this statement, so it is not different, force per unit mass.
Uh,
Okay. Actually, this is same as the definition of gravitational field strength, right? Force per unit mass. So we will talk about that in detail, because as I told you, that this is the topic which is extensively described in gravitational field. So that's it for this one. Now I'm going to talk about that if there is a force, then definitely that force would have some direction, because here it is mentioned that it is force
force is
per
vector.
unit. So force is a vector quantity, so definitely it must have a direction. So remember one thing, that gravitational force is every force that is represented by a line or any lines, those lines are called field lines. What do we call these lines?
Field
These
lines.
lines are called field lines. So If these lines are for electric force, they are called electric field lines. If they are for gravitational force, they are called gravitational field lines. If they are representing magnetic force, they are called magnetic field lines, and so on. So here, because our concern is gravity, so I will call them gravitational field line. So gravitational field lines show the direction of the gravitational force is towards the center of any mass, towards the center of any mass. It means that this all force is concentrated at this center. That is
So,
why
so a constant, the lines show.
the lines show the direction of force.
Okay.
Okay, so what does these lines show? Lines show direction of force,
Yeah.
direction of force. Okay, I
Yeah.
mean gravitational force. So as the concentration of the lines is different for different masses, that's why if there are concentrated lines, closer lines with each other, they show
Yeah.
that the gravitational field strength
Concentrated.
is greater or
Yeah.
stronger gravity is there. Okay,
Yes.
is this clear to you? For example, if you are having gravitational field lines around a planet or around the surface of a mass, and there is another one around which less number of field lines are shown, so you have to, I mean, you have to notice, or you have to comment on that, or you can tell that yes, that planet which is surrounded by, or around which we are showing less number of gravitational field strength, its gravity is weaker. Okay,
Mm.
is it
So
clear to you?
concentrated lines show strong force. When it is not concentrated, it shows weaker force.
It's a weaker force. Yes, it's
Okay.
simple. So, is it visible to you? So,
Sir, what does a concentrated line mean? Like, how
I
do
mean, I'm showing. I'm showing here. Concentrated means that if this is one of the planets, and I'm
yeah.
going to show another planet here, it is of the same size, but this planet is having a huge number of, I mean, a lot of lines around it. Okay, so when there are a lot of lines around it, I can say that the concentration of the field lines is more here. They are very closer to each other.
Yes, sir.
That is why this planet has stronger field than that one. But actually, I why I have selected this word concentrated, because as you know, or as you see, as I'm moving away, check this one out. Here, the field lines are having more separation. Is it?
Yes, sir. Yes, sir.
And here the separation is smaller. As I'm coming closer to the center of the planet, the lines are getting closer and closer and closer. This shows that actually the field is getting stronger and stronger as I move from outer sides to the center of the planet. Okay, is it clear to you?
Okay.
Okay, now move to the next. That uniformly spreaded lines show the uniform field. Actually, this is what I'm talking about. The properties of properties of the gravitational field lines to somehow that if the field lines are uniformly spreaded, it means they show that the field is uniform there. Are you
Okay.
getting it? Uniformly
Yes.
spreaded lines ये होती हैं कि they have equal distance. What do they have? They have equal distance throughout. So if we have equal distance between the lines, so I can say that the field is uniform there.
Yeah.
Any confusion?
No, sir. So a uniform, matlab, each place is getting the same direction of force.
Um, Uniform mean that gravity is acting equally, or the strength of the gravity is equal at every point. For example, if I draw a diagram for you, it is just a part of the earth, a building size part of the earth. Although I would not be able to draw that part, but I will just make you clear, inshallah, that for example, if I say that this is a small building, I mean it is a huge building but on the earth. So
Yes,
as
sir.
compared to that of the, as compared to the size of this earth, if
Yes, sir.
I just zoom this out, this part,
Yeah.
so
Yeah.
will you say that it is just a flat part of the earth, this one? It appears like this, that earth is straight where you are making the houses.
Yes,
Earth
sir.
is straight where you are going to build the buildings. So that is why if I say that okay, this is a straight part where I'm going to build a house, so that means that gravitational field strength is uniform there. So at the building level, or at the level of building, or at the size of building, actually the gravitational field strength is uniform. That's why your homes are, the buildings are not pulled unevenly by the gravity, they are
Yes,
being
so sir.
pulled evenly.
So sir, basically, there's no resultant force acting upon it. Yeah, because
No,
if
no,
it's
no, 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 I mean to say that if gravity is, if attracting it unevenly,
yes,
तो
sir.
possibility है कि ये
Yes.
वाली जो wall है, it would be attracted more, right? Or it
Yeah.
would be attracted in this way towards here. ठीक?
Yeah.
This would be attracted downward exactly. This wall will be, so it will collapse, isn't it?
Yes, sir.
So here actually this is incorrect path. So the correct description of the gravitational field line is that all the field lines are behaving like they are attracting it इक्वली
Yeah.
डाउनवर्ड. सो एक्चुअल मेरा कहने का मतलब ये है कि जब हम लोग बिल्डिंग साइज पे आते हैं तो ग्रेविटी डज नॉट हैव any uneven
Effect.
behavior. It field lines are evenly spreaded, and when field lines are evenly spreaded, we say that the gravitational field strength is same all around. Okay,
Yes, sir.
so at the size of the radius of the earth is long, it is actually a question what I have addressed, that as the size of the earth is very large, or large enough, so lines becomes straight or parallel at the surface of the earth. That's why they show that the earth is having a uniform field around it. Okay, this was the question, so I just addressed it over here.
That
A
line
theory part.
becomes so held.
Which part? The size or the radius of the earth is so long, or
Yeah.
long enough, so gravitational field lines becomes parallel. So here one
Parallel.
word is missing, parallel. So field at
Yeah.
the surface is uniform,
So
right?
field. Yes, sir. Yes, sir. So field at the surface is uniform. Yes.
Uniform.
Okay.
Now we will talk about the radial lines. Actually, if I just go back to this diagram, it was a good diagram, so I can refer you back to this diagram. Check this one out. Do you see that these lines are along the radius of this planet? If I just imagine, I'm
Yes, sir.
drawing them inside it. So
Yes,
they
sir.
are along the radius of this. So that's why they are called radial lines, right? So
Oh.
field lines are actually radial. So they have, are they actually act along the radius of the sphere. This has two meanings actually. एक तो ये कि they all are concentrated at the center of the at the center of the planet, which makes that planet a point mass.
Okay. 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 Wait. It's concentrated at the center. So the center of the Earth is the point mass.
It shows that all the force is actually here, na? These lines show that although they are just till the surface of the planet, but when I talk that they are behaving radially, so they will act along the radius. So does it show that the origin of the force is the center?
Yeah.
Yes. So this shows that I will not consider the whole earth as a mass, or
Point
the force
mass.
is acted by the entire earth on the other body. I will just consider that this green part of the earth, I mean the nucleus or the center of the earth, this is that part which is providing the gravitational force. This is actually that earth is behaving just like a particle of mass. Earth is behaving like just like a point mass. So this was actually the point I had to discuss with you. So I believe that it is clear to you. So do you have any question related to that?
Yes, sir. No, no. According to this, no. But sir, so that means that the origin of all the mass is concentrated at the Earth,
At the center, yes, exactly.
at the center of
It
the Earth.
means
Okay.
this,
So, sir, it's
right?
like an atom, yeah. But everything is concentrated
Exactly.
in the nucleus.
So
Yeah.
either you can use the word the particle,
Yes.
or you can use the word point mass.
Okay.
Okay.
Yeah.
Second thing what comes to our mind when we use this word, that these lines are radial, that shows that radius is always perpendicular to the tangent to the surface. That means that these lines are perpendicular to the surface all the time,
Uh, oh, these are the
right?
perpendicular
So
to
I
the
can
center.
write, yeah, I will write it for you, that the lines are perpendicular to the surface.
What lines?
These field lines, these
Tiered
actually
lines. Okay.
gravitational field lines,
Or perpendicular to the surface. Okay.
perpendicular to the surface. That is why they never intersect each other at the surface of the planet.
Perpendicular to surface.
Okay,
Perpendicular at the surface. So they never.
intersect each other at the surface of the planet. Is it clear to you?
Yes, sir.
Okay, should I move forward?
Um, yes, sir. You can move forward now.
Okay, now the situation is actually um, beyond the theory part.
Okay.
Till this point, I just discussed some theoretical aspects with you. Now
Yeah.
we will have some calculations, analysis, and everything which would be asked to us. So, gravitational force is the main topic here. And when we talk about gravitational force, force due to mass of any uncharged or unmagnetic object, when that object will provide a force, that is called the gravitational force. So simply
So
say that every mass has gravitational force, right?
yeah. Yes, sir. Every mass.
Every mass,
Yeah. I agree. Yes.
either it is charged,
No, no.
magnetized, or
Only uncharged.
whatever.
Uncharged.
I mean, no. I mean to say that if a body is neither charged nor it is a magnet, but
Yeah.
despite of this, it is exerting some force on you. Sorry,
Yes.
on the other body. It
Yeah.
means that force is the force of gravity. It is not the fictitious force that we are unable to identify. That is the force which can be coming from the graviton. if you have read about the particles, although we have not yet discovered graviton, but we have a strong belief that there is no other particle who is the force mediator or who is the force carrier of this gravity. But we believe that this gravitational force is force due to a mass. So is there any object without mass? Is there any object in the universe which
Yes, sir.
exists without mass
Yes,
other
sir.
than energy?
Yes, sir. So
Which is
anti-neutron.
that?
Anti-neutron.
Antineutrino?
Yeah.
In calculation, it has no mass, but practically we
Oh.
cannot refuse its mass, or we cannot declare that it is massless. Its mass is negligible. Why
Ah,
don't
okay.
we write mass on the electron?
So electron has mass.
Electron has mass, but we don't write the mass number on the
Oh, yes,
electron,
sir.
you
Yes,
know.
sir. Yes, sir. We don't.
That is the reason. So this is mass force due to the mass
Yeah.
r.
Sir.
What is the responsible particle for this one? So as I told you, that is a graviton,
Yes,
right?
sir.
ये क्योंकि तुम AS में भी अभी appear हो रहे हो, so that's why I just discussed this point with you. Otherwise it is not in your syllabus. A2 में नहीं है what is responsible for this mass, but sorry, for this force, but we should know this thing. It's the part of the game. They are from where this force is coming out of nowhere. So
Okay.
gravity आपकी ना, that is immense force. It is coming out of nowhere. हमें कहीं पे भी gravity मिलती है, everywhere,
Yes, sir.
right?
Yes, sir.
Okay, so I can say that, I mean, this is just a perception that the force due to a mass of any uncharged and non-magnetic object. Now back to the point. इस पे बात कर लेते हैं. Oh, I have written that for you as well, and for any other student. Graviton is the responsible, or supposed to be responsible for the gravity. Now come back to the A2 syllabus. Law of gravity. It is asked to you for 2 marks. But before coming to this, I would let you know that whenever there will be two masses, at least two masses. I mean, ईमान का आखिरी दर्जा है कि दो मैसेज का होना जरूरी है. So if
Yeah.
there are at least two masses,
Yes.
then this gravity will be observable. Otherwise, it will not act on a single body, or it will not be created by a single body. Sorry, it will be created by a single body, but it cannot be detected, or it cannot be experienced until unless you are not having any other mass. So remember one thing. That's why this law is stating for two masses. For the
Yes.
force of attraction, as I mentioned, that this force is the only, I mean, this is the only attractive force. It does not have any repulsion. So the force of attraction is directly proportional to the product of 2 point masses. I have written this exam definition, so I will not change the words of this. I will make you clear with different statements, but you will not change the statements. You will not change the words when you are going to score some marks in the exam. So force of attraction is directly proportional to
The
the
product.
product of 2 point masses. Remember one thing, it is mandatory to mention this. There are 2 point masses, right? It is
The
mandatory,
and inversely proportional.
right? And
Yes, sir.
inversely proportional to the square of, again, it is very important, square of the separation between their centers. Never write the square of distance between their centers. It is inversely proportional to the square of separation between their centers. So is this very clear to you? Will you be able to recall this? You have to
The
recall
force
it.
of
No
attraction is
understanding.
directly
Recall it.
proportional to the 2 point masses and inversely proportional to the square of the distance between the centers.
Every student can score 1 mark when the student write that force is directly proportional to the product of masses and inversely proportional to the square of distance between their centers. But you will not score 2 or 3 marks here. 1 mark only. Actually, you are explaining that mathematical relation. You are not explaining the physical principle, right? So be careful about that. You have to mention all these terms what I have declared here. So
Okay.
let's have its mathematical explanation. That if we have two masses m1 and m2, and they are at a distance r, or they are separated by a distance r from their centers, then according to the law of gravity, these two masses would attract each other. This, if I change their colors, it would be, more convenient. That if this is a green body, right,
Yes, sir.
then the green body is attracting this red one by this force. This
Uh,
is the force of
the green body.
2 at 1,
Uh,
right? And then this red one is attracting this green one by this force,
yes, sir.
right?
Yes, sir.
So this is the force of body 1 on body 2. So both of these forces are inwards towards each other. So I can say that actually this is a single force, right?
Uh,
So
okay.
when I say that is a single force by which both the objects are attracting each other, so that single force is directly proportional to the product of 2 point masses. As I told you, that the origin of the mass or origin of the mass can be considered at their centers. So that is equals to F1. F is directly proportional to M1, M2, and inversely proportional to the square of separation between their centers. So I have two mathematical expressions. I have just combined them here. That M1 will have a constant here. So F is equals to constant into M1, M2 divided by R square. And the constant is actually this G. That is the constant here. So be very careful about this constant. It is universal gravitational constant. What is that? It is universal gravitational constant. So that constant actually tells us that these forces, these masses will have a relation, but they will have a multiple, a universal multiplier.
Yes, sir.
Okay, and what is
F
its value?
9.81. Oh, no, wait.
Hmm?
6.63
No,
times 10 power
it is
minus
not.
11.
Hmm.
Yeah.
It is not small g. Small g is equals to 9.81, but it is not like that. Just cut it.
Uh-huh.
This is what? Universal gravitation constant, and its value is 6.63 into 10 raised power minus 11. It is very small value.
Yeah.
Newton meter square per kg square. So you have to remember this expression. You have to recall it. In your syllabus, it is said that recall this expression. Okay? अब आप देखो, the problem is, okay, if I want to calculate the value between two forces, for example, our average mass is 80-60 kg, itni hoti hai na.
Sir.
If there are two persons who are sitting or standing in front of each other
Yes, sir.
at a distance of 0.5 meter, and their masses are 80 and 60 respectively, so what force will they experience?
Yeah.
I have calculated that for you. Don't worry. It is
Yeah.
1.27 x1 minus 6 Newton. Micronewton, 1.3 micronewton. It's really, really, really small. Okay?
Yeah. Yes,
Because
sir.
if
Very
that
small
force,
mass.
sorry,
The mass is very small.
no, 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 masses are not small enough. 80 kg is considerable mass, but gravitational force is so weak. This is what I wanted to tell you. That masses are significant. I mean, 50, 60 kg is ordinary mass. And if a person is standing here and that person is trying to lift a 150 kg weight, sorry, 150 kg mass on the
Yeah.
surface of the earth.
Yes, sir.
ठीक है, वेट लिफ्टिंग कर रहा है कोई बच्चा, सो
Uh,
150 kg का कोई लोड उठा रहा है, आई मीन केजी का उठा रहा है, so how much force does that guy needs to make this dumbbell free from the earth's gravity? Not actually from earth's gravity, just to pull it out, pull it up. How much force do we need?
सर बंदे का मास क्या है?
बंदे का मैच नहीं है, बंदे का मैच अभी जरूरत नहीं है, बिकॉज बंदा इज स्टैंडिंग ऑन द अर्थ सरफेस। जिम में गया ना, अब यूं समझ
हाँ
लो आप जिम में बैठे हो, यू आर ट्राइंग टू लिफ्ट दिस ब्लैक वन। ये ब्लैक वन वाला क्या है? दिस इज द मैच, डंबल है ये, क्या कहते हो इसको? वेट कहते हो ना।
जी जी सर।
ये बंदा 150 केजी लिफ्ट कर रहा है। सो
जी। Then why do you not have? Why you said there's two? There must be two masses. So is it the mass of the Earth and also the mass of the dumbbell? Yes, sir. 6.0 times 10 power 24. Yes, yes. So the answer should be around 6.3 times 6.3 times. So around what? So I got a very big number, like very humongous number. So I got 1,456 or 1,500 newtons. सर आपकी आवाज नहीं आ रही.
सॉरी, माय माइक वाज gone, its battery was discharged, so I have plugged in it again. अब आ रही है? हेलो, डू यू हेयर मी अब्दुल्ला?
हाँ यस सर आई हियर यू सर.
ओके ओके, वो माइक की बैटरी डाउन हो गई थी ना, सो आई हैव टू प्लग इट इन। अच्छा, मैं ये कह रहा था कि यू हैव कैलकुलेटेड 1500 न्यूटन। सो टेल मी वन थिंग, if I just ask you, regardless of this all calculation, you calculate the weight of 150 kg, so what would be your answer?
सर 1,500 न्यूटन approximately.
Approximately, perfect. So what answer you got here? Approximately,
1,500 Newton.
isn't it the same one?
Yes, sir. But yeah,
So can I say that weight is the force by which Earth attracts every object towards its center?
yeah, yes, sir.
Now can you define it na properly? Because आप बचपन में ये पढ़ते थे, weight is the force by which Earth attracts everything towards the center. That's it. But here you performed it. Yes, that is.
Yeah. The weight is equal to uh,
Weight equal to the force by which
by
Earth,
which
the
uh,
planet, I mean,
so not even planet. It's not just like the body or is it
any
only
planet,
planet? Any planet, planet.
I mean any mass, actually bigger mass, क्योंकि
Yeah,
weight
any
आपके
mass.
पास significant force कौन दे सकते हैं?
Sir,
Planets दे सकते हैं ना?
even the sun has a gravity.
Yes, yes. The sun
Yes,
is a star, but any big mass, I can say,
yes, sir.
equal to the force provided by, or the force acting on a mass
Uh,
due to gravity of a bigger mass, a giant mass like planets, stars, etc. Is it?
yes, sir.
So आप अब define कर सकते हैं, weight is the force by which earth attracts everything towards. Actually we perform all the experiments on the earth ना, तो इसलिए बच्चों को ये चीज बताई जाती थी कि weight is the force by which earth attracts everything towards its center, है ना?
Yes, sir. Acting on the mass due to gravity of a bigger mass.
Is this yani does it make a sense?
Yes, sir.
ओके, अब आप लोगों को इस फोर्स की कुछ प्रॉपर्टीज बतानी है, बिकॉज दोज आर द प्रॉपर्टीज विच आर इंपॉर्टेंट फॉर दिस फोर्स. दिस इज समथिंग यूनिक. आई मीन, क्योंकि हम लोग ग्रेविटेशनल फोर्स के बारे में पढ़ रहे हैं, सो वी शुड नाउ लॉट ऑफ थिंग्स अबाउट दैट. सो द फर्स्ट वन इज दिस इज attractive force. It has only attractive nature, right? It has
Yes,
no
sir.
repulsion. No repulsion. तो हमारा वो लाइक चार्जेस और लाइक मैसेज और लाइक पोल वाला तो कॉन्सेप्ट गया, राइट?
Yeah.
सेकेंडली, आई कैन से दैट दिस इज वेरी इंपॉर्टेंट. और भी है बहुत सारे, बट आई वांट टू राइट दोज only which are mandatory, without which your concept will not be completed. The second one is the force acts on both the bodies. I mean, both the bodies का मतलब क्या है? The bodies which are under the relation
Yeah.
of the force, I mean gravity, उन दोनों के ऊपर आपके पास at a time force act करती है. The force acts at both the bodies equally, but the impact of the force is on the smaller body. Do you know?
It's much greater.
Yes. No, no, no. Force will not be greater for that.
So
But
the impact
impact
is
of
greater.
the force,
Yeah, impact, impact,
yes.
impact, impact is greater.
Impact of force is greater for what?
The
Smaller
small
mass.
bodies. Yeah.
Because it needs very small force for acceleration for smaller mass. And that is why it accelerates. It has acceleration. अब देखो, आपका आप एक बॉल को अर्थ पे ड्रॉप करते हो, so you know what happens.
So, as the
Earth,
ball is falling, initially it only has gravity, but as it moves down,
this is
it
the
gains
force
it.
of force
Earth.
on ball, right? And if
Yeah.
I say this is the ball and the ball is exerting a force
On
equal
the earth.
on the earth,
Yeah.
लेकिन अर्थ के लिए वो फोर्स ना होने के बराबर है, कोई
Uh,
फील ही नहीं होता इसे, राइट?
yeah.
फोर्स ऑन अर्थ.
So
तो
how much
इसलिए अर्थ ऊपर
force?
नहीं जा सकता.
So how much force will it take until the earth has an impact?
We need a big planet closer to
Uh,
it. I
uh,
mean, for example, if I want to accelerate the Earth by an acceleration of just 1 meter per second square, 1 meter per second square,
yeah.
तो मुझे कितनी फोर्स चाहिए होगी? आई कैन कैलकुलेट बाय एफ इक्वल्स टू एम ए के फॉर्मूले से मैं कर सकता हूँ
Yes, sir.
दैट एम ऑफ द अर्थ इज वेरी बिग, सो व्हाट फोर्स डू यू नीड? जस्ट कैलकुलेट करो. इट वुड बी ऑलमोस्ट 6.0 इंटू 10 पावर 24
Uh,
न्यूटन. अगर इतनी फोर्स आपको कहीं से कोई प्लेनेट देगा, तो इट इज पॉसिबल के अर्थ आपकी थोड़ी सी एक्सेलरेट करेगी. आई मीन 1 मीटर पर सेकंड स्क्वायर इज नॉट अ बिग एक्सेलरेशन,
oh,
बट हमारे लिए बहुत बड़ा एक्सेलरेशन है. बिकॉज if earth has an acceleration of even 1 centimeter per second na, so there would be a lot of motion taking place on the earth, so it will cause a big big earthquake on the earth,
yes.
right? Is this all clear to you? Okay, जो फोर्थ पॉइंट आपको याद रखना है, इट फॉलोज इनवर्स स्क्वायर लॉ. ठीक है?
Yes, sir.
आपकी ये जो फोर्स है ना, यहाँ पे एक छोटी सी बात और ऐड कर लूं कि बिकॉज इट इज अट्रैक्टिव, दैट्स व्हाई इट हैज अ नेगेटिव साइन. नेगेटिव साइन इसकी वेक्टर नेचर के लिए नहीं है. नेगेटिव साइन इज ड्यू टू इट्स अट्रैक्टिव नेचर. नेगेटिव साइन हम लोग ऐड करेंगे यहाँ पे. इट फॉलोज इनवर्स स्क्वायर लॉ. ये जो फोर्स है ना, इट फॉलोज इनवर्स स्क्वायर लॉ. ओके.
Inverse square law.
राइट. सो इनवर्स स्क्वायर लॉ का मतलब ये है कि इफ आई हैव मीन इफ द डिस्टेंस विल बी इंक्रीज by 2, if f is, let's say, f, and r is r, then if r is 2r, f will become f
Ah,
by 4.
okay,
At 3r, it will become f by 9. At 4r,
F
it
by
will
16.
become f by 16, and
Yes.
so on. So in this way, if I plot a graph of this, so that graph will be very simple to plot. के आपके पास inverse square law का graph बनेगा. And I believe that you are clear about inverse square law. Okay. Right. Inverse square law ये होता है कि for example this is your center, right? This is center. I mentioned that this is center.
Yes. Center of the earth, yes.
Center of the earth. ये कोई center बना नहीं है unfortunately,
Hmm.
but it is the center. So if I say, okay, now it seems to be center. Okay, so this is your r. If I move this at the same distance 2r, for the same distance 3r, same distance 4r, 5r, 6r, and so on. This is the distance, or you can say x, and this is basically the force. So force will be maximum at any position. Here, let's say here, this force is
It's maximum.
maximum at
Maximum R. Yeah.
here. जब आपने
Yes.
2r किया तो it would reduce to 1/4.
Yes.
So where it will be at this position.
Yes.
अब आपने इसको 3 times किया तो it will reduce more. Let's say it is 1/9, and so on, and so on, and so on. It will not touch the axis. You know why? Because it will touch the axis at infinity. आप आर को बढ़ाते जाओ, बढ़ाते जाओ, बढ़ाते जाओ, बढ़ाते जाओ. So ये स्मूथ होता जाता है ग्राफ, but it
Yes.
never touches the axis. Initially it drastically changes because
Yes.
of its inverse square relation, but later on the changes become smooth and smooth and smooth. So remember one thing, that case का graph कभी भी axis को touch नहीं करेगा. Is it clear to you?
Yes, sir.
Okay. अब मैं आपको ना एक बहुत इंपॉर्टेंट क्वेश्चन की तरफ लेके जा रहा हूँ. एक्चुअली दैट इज द मोस्ट इंपॉर्टेंट क्वेश्चन आस्क्ड फ्रॉम द टॉपिक ऑफ फोर्सेस, फ्रॉम दिस टॉपिक. दैट इज द वेरिएशन ऑफ द वर्क. ये तो एक सिंगल बॉडी के ऊपर मैं बात कर रहा था ना. नाउ
Yes,
आई
sir.
विल टॉक अबाउट द वेरिएशन ऑफ force for a test mass, for a test mass, minded test mass, while moving on a line joining the centers of two masses.
Yes.
Is this description clear to you? That what I want? If I have two masses, for example, this is mass 1, right? And this is
Yes.
mass 2, right? And these two masses are joining. They have this separation between their centers. This is the separation between their centers. Okay, let's say
Yes.
this is a line joining their centers. Here I will mention that the distance between their centers is this one.
Yes.
ठीक है जी? Is this clear to you?
Yes. Yes, sir.
Okay, so this is the separation. तो अब आप
Yes.
मुझे ये बताइए, this separation is R from their centers. So this one is MA, mass A. This is your mass B.
Yes.
Okay, is this clear to you?
Yes, the
So
mass. Yes.
if I have a small object which is basically
In the center.
placed at different positions, let's say this is a point, this is a point, this is a point, here is a point, and this point mass has a small mass m. इसका mass कितना है? Small m, right?
Yes.
अब
Yes.
आप मुझे बताइए कि if I consider these all points as p, q, r, and s, so what about the individual forces at p, q, r, and s? I
Sir,
will
force is the highest when the R is the smallest. So should be P because F is inverse proportional to R square. So
okay, मेरा
yes, sir.
क्वेश्चन ये है
Yeah,
कि let's say this is the planet, I mean this is the mass with red color ma, so
right.
it would, do you think that the largest force will be at p, the force will be larger for larger due to this one, right? Fa will be
If
towards
they if
this,
they if they have the same mass, yes, yes, sir.
it would
Should
be
be.
decreasing,
Yeah, should be decreasing.
decreasing, and decreasing. Do you believe this thing?
Yes, sir.
So this is Fa. So Fa is decreasing, 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 and decreasing. What about Fb? What do you think?
Sir,
Let's say
F.
that is a planet with blue color. I'm just going to indicate the forces. That's why. So this force is smallest here, it is gradually increasing, right? And here let's say it is equal to f a, and now it has been increased more than that. So can I say that f a and f b are opposite in to each other, but as it moves towards surface of b, the force of fb increases?
Yes,
Do
sir.
you agree?
Because yes, yes.
Okay. If you're agreed,
Hmm.
then are you agreed that the force is, just a second, the net force is basically the difference of these two forces?
Yeah.
Is it?
Yes.
So can I say that F net is this way, F net is this way, but it is decreasing in
Yeah.
magnitude?
And then
Here
there's no
it
F
is
net.
0.
Yeah.
Yes, and here F net is increasing again, but
Yeah.
opposite in direction.
Yes.
Can I say that? This is
Yes.
your F net, right? Which is basically FA minus FB.
FB.
So
Yeah.
actually, this question is asked for many times to describe the behavior of the force. So here I have mentioned this thing that your F is zero actually. Should I name this point other than X, other than R, because R आपको confuse करेगा. Let me make it a point W. Okay,
Okay.
although it is odd to write W in between P Q के बीच में लिखना, लेकिन just for the convenience I'm writing this. So F is zero over there, and then F is increasing in opposite direction. So if someone asks you, सबसे पहला क्वेश्चन आपका आता है 4 marks का, right? 4 marks का क्वेश्चन आता है,
Okay.
describe the
Yes.
change in yeah, describe the variation in force. Describe variation in force. It is a 4 marks question. So how will you write that? That
Sir, you can
FA,
say that as as the R increases, the force
yes,
FA decreases and FB
good, good,
increases
in opposite direction.
in the opposite direction, uh, and that the resultant force decreases until it reaches point of zero,
Yes.
and
Here you
then
will just
yeah.
mention one thing, that F net or net force is the difference of both forces, right?
Okay.
That is why, right? It is just to mention here, F net is the difference of both forces. So it decreases to
Zero.
zero, where, here I'm going to mention this thing, where
Where FA is equal to
both
FB.
the forces are very good.
Yeah.
Both forces are equal and opposite.
Yeah.
Both forces are equal and opposite. Is it clear to you?
Yes, sir.
Okay. And right after that, what happens to the F net? Then,
It increases in the opposite direction.
yes,
Yeah.
FB becomes greater than FA. It is just an additional thing. It would not award you mark, but it is just for the concept. Then FB increase becomes greater than FA. So F net increases again in the opposite direction. So F net increases again in opposite direction. Is it clear to you?
Yes.
So here are your 4 marks. If you will write it, you will secure all these 4 marks. आपसे 3 नंबर पूछता है तब भी आप ये सारा लिख दो. इट डज नॉट मैटर कि यार आपको 4 नंबर के लिए पूछा गया है या 3 नंबर के लिए.
Okay. Yes, sir.
ओके. उसके बाद आपके पास आता है ग्राफ. This is the second aspect of this topic. Okay, if I draw the graph, do you think that this graph will be basically into two quadrants? क्यों? क्योंकि आपके पास
FA
जो
and you have
फोर्स है,
FB. Yeah.
yes, FA and FB are two forces. I'm just going to draw the line. I will try my best to draw the line according to the without ruler. ये देखो. So red वाले की force क्या थी? Red one was decreasing, so I'm going to draw it with red. This was FA.
Yeah.
And what about the blue one? Blue one
It was
was
increasing.
smaller there, but it will increase in this
Yes.
way.
Yes.
What about the net force? Black one.
So
It
net
was the
force
difference
will
of
be
both.
it will decrease to zero and then it increase on the other side. Yeah.
Yes, perfect. Very good. So this was your FA.
Yeah.
That one was your FB, and this sorry, blue one is FB, and black one is FNet. So here is the point which I mentioned you, that this is that point W. है ना? Here
Hanji.
FA is equal to FB but opposite in direction. So this is the graph. I believe that it was very easy to after that description. अब calculations पे आ जाते हैं. Calculations are actually we are asked to calculate that the point where FA is equals to FB. We have to perform calculations right at that point. So for that purpose, I just redraw that diagram. I will try to bring it as a copy of this, inshallah. If I would be succeeded, then no need to draw it back. Oh yes, I was successful. Okay, now is it visible to you? The same diagram I have copied here. Check karo. Let's say I will erase rest all of the points what I have discussed earlier. So I'm going to erase this all. Forces का भी concept erase कर देना चाहिए, but just no issue, because when I will try to erase that one, my rest of the diagram will be just slaughtered. देखो, this is the distance d
Yeah.
isn't it your r minus d?
Yes. Yes, sir.
Okay, so I can simply say that this is the point where I have to find out that whether um, this is the position here where both the forces are equal and opposite to each other. Force of A is equal and opposite to force of B. तो अब मुझे ये बताइए, if I just put the values here, FA is equals to FB. So what will be FA? As you now, this is your small m, okay,
Sir,
small m,
M1, M1, MA,
E
M, M,
M
G, M1,
A
G1, M1, MA, over, over R square, over D square, sorry, D square, D square.
D square.
Yeah.
Very good.
Yeah.
And what about
G,
this one?
G, M, B, M over R minus D square.
Well done.
Yeah.
That will be R minus D whole square. Now, if I cancel few of the parameters here, I will be left with mass of A divided by D square equals to mass of B divided by R minus D whole square. Okay, so here is this formula. This formula will be required to calculate several asked values. For example, जो सबसे पहले आप लोगों से पूछा जाता है, रेशियो ऑफ मैसेज कैलकुलेट करने का पूछा जाता है. फ्रॉम दिस वन यू कैन कैलकुलेट रेशियो ऑफ मैसेज ऑफ दोज प्लैनेट्स. इसके लिए ये सारा काम हो रहा है. फॉर दैट वन यू नाउ एम ए divided by mb, that is equals to d divided by r minus d whole square. Are you agreed?
Yeah. Yes, sir. I agree.
Sure.
Yeah.
आपको इक्वेशन में वैल्यूज प्लेस करनी है एंड यू विल फाइंड व्हाट इज द mass रेशियो ऑफ masses ऑफ दोज बॉडीज. उसके बाद अगर आपको डी कैलकुलेट करना पड़ जाए कि एट व्हाट डिस्टेंस दिस विल हैपन ऑल, ये जो मैंने किया सारे का सारा, फॉर दैट पर्पस व्हाट यू हैव टू डू, you have to go back to this point ma divided by mb, that is equals to d divided by r minus d whole square. Do nothing, just mathematically take square root on both sides.
Yeah.
ठीक है.
Yeah.
तो जब आप स्क्वायर रूट ले लेंगे तो डेफिनेटली आपके पास बहुत सारे ऑप्शंस आ जाएंगे. दैट mass of a divided by mass of b, that
Square.
is equals to d divided by r minus d into square, I mean square root of this. So from here you can, I mean I'm not going to derive this all के d का फार्मूला क्योंकि आपने याद तो नहीं रखना. You
Yeah.
just now this trick and put the values and solve for
Solve for D, sir.
d.
Yeah.
Is it clear to you?
Yes, sir.
Yes, this is all about gravitational force. Gravitational force का मीन ये comprehensive details मैंने आपको बताई हैं and I believe that it will help you a lot. Okay,
Yes, sir.
मैं एक क्वेश्चन आपको दिखाता हूँ. I believe that it will be really helpful for you. अगर आपको ये टॉपिक समझ आ गया, ये जो मैंने अभी आपको समझाया है, तो it will be really great. I'm just
Yes,
going to
yes.
switch the screen. to another browser, and there I will find some of the questions of your interest, और आई होप कि इसी तरह के क्वेश्चंस हमें मिलेंगे. ओके. यस, आप कुछ कहना चाह रहे थे, सॉरी.
No, sir. नहीं.
Here is that the gravitational field worksheet. Okay,
Yes, sir.
a lot of questions are there. Let me just find what we have studied. Yes, there are several questions which can be asked from the same topic. Yes, this is that one. Oh, sorry. This is binary question, binary one. Gravitational forces का question, gravitational potential का question है. Here I have that question for 4 marks. I will let you know about that. फिर हम लोग उस पे बात कर लेंगे. Gravitational field strength. Yeah, this is that question. Check this one out.
Okay.
Right. So we can find the speed by the same gravitational field strength topic. ये कुछ circular के question अभी भी हैं इसमें, because that was a combined worksheet when we were practicing that stuff. तो मैंने इसमें से निकाला नहीं है gravitational field strength के जो questions हैं. Gravitational, I have just named all the topics, right? Questions का मैंने वो दिया हुआ है. Yes, ये सारा ये वाला क्वेश्चन आपका प्योरली इसी टॉपिक का है. चेक दिस वन आउट. आई बिलीव दैट यू विल बी एबल टू handle this gravitational law, right? State Newton's law of gravitation. So I believe that you will be able to do that.
Yeah. Force of attraction directly proportional to the product of two point masses and
Point
inverse.
masses.
Yeah, point masses and inversely proportional to the square of the distance between the two centers of the mass. Yeah.
Okay, and inversely proportional to the square of separation between their center.
The two centers of the mass. Yeah.
Yes, the Earth and Moon to be considered as isolated in space, and their masses are concentrated at the center.
Yeah.
The orbit of the Moon around the Earth is circular, and it has this much distance, 3.85 into 10 is about 5 kilometer, and it completes it in 27.3 days.
Yeah.
Okay, show that the angular speed of the Moon is orbit. ये देखो, ये question आपका मैंने कहा था कि it is coming from your chapter number 1 circular motion, but that is here.
Yes,
So
sir.
how will you calculate that angular speed?
Probably is equal to 2 pi by t.
Time is in days, so you have to convert that one.
47.3 times 20 times 24 times 60 times 60 or times 3600.
Yes, calculate करिए.
2.3 times 24 times 60 times 60. Sir, 2.66 times 10 power minus 6. 2.664. Yeah. Yeah.
Right?
Yes, sir.
Is it the same? You scored 1 mark.
Yeah.
Okay. Now
Yeah.
you have to show that the mass of the Earth is this much.
Yes, sir. Sir, can you go up? What do they give the force? Maybe a little bit. Okay. The mass of the Earth.
Mhm.
So do you use the F is equal to G as well
This
to
will again, sorry, it will consist of another formula.
oh,
That is that time period square is directly proportional to orbital radius cube. We will discuss that in later on. So just cross it. ये देखो, mass of the moon is given to you. Using the
yeah,
formula, you have determined the gravitational force between, because you have calculated mass of the Earth. You have calculated, I mean, you have given by the mass of the moon. So just put the values here, and you can find the gravitational force. Okay.
okay.
Okay. इस तरह के questions आएंगे. I will find some other questions for you, and then I will send those, inshallah. Okay.
Yeah.
Okay. So is it fine till now?
Yes, sir, up till now it's fine.
उधर थक गए हो?
Nine.
नहीं था क्या?
नहीं.
अच्छा ठीक है. सो आई एम गोइंग टू स्टॉप इट हियर. नमाज पढ़ो और फिर वापस दूसरी क्लास शुरू करते हैं.